Welcome to the AI Checkpoints. Today, we're embarking on a really fascinating deep dive into something called deep agents. Now, if you're keeping an eye on AI, you know agents are a big deal, but deep agents, well, they feel like the next generation. They're designed to tackle truly complex, multi step problems, more like entire projects, really, not just quick tasks. Our mission today is to really unpack what these deep agents are, why they're so powerful, and importantly, how they're actually built. We're pulling our insights directly from some great material by the LangGraph YouTube channel, specifically their videos, What are Deep Agents, and the technical walkthrough one. And as always, we want to give you that shortcut, right, to being well informed about the real cutting edge of AI development.
Absolutely. And what's particularly compelling, I think, about deep agents is how they move beyond those simple sort of one-off interactions. They're really designed to orchestrate complex operations, often over long periods, almost like an intelligent project manager.
Yeah.
You know, one that sees the big picture but can also dive deep into the minutia when necessary. It's a pretty significant leap in AI autonomy.
Okay, so let's unpack that a bit more because when we talk about AI agents, yeah, maybe you first think of a tool that does a quick search or answers one question. Useful stuff, no doubt. But deep agents are like in a whole different league. The LangChain sources really emphasize that they're built to operate over long time horizons and to delve deep into complex problems, and then this is key bubble back up to achieve those high level goals. We're talking about AIs that don't just solve step one, but can manage the whole journey, kind of like a human expert would, right? And LangChain points to some impressive examples already out there, like Claude Code.
Which has turned out to be surprisingly good at more than just coding, yeah.
Right. And Manessa and OpenAI's deep research agents, too.
And if we connect this to the bigger AI picture, it's really crucial to understand that deep agents aren't based on some totally new, like, magical algorithm. Fundamentally, they use the same basic tool calling loop as simpler agents. That pattern often called React style, for its iterative flow.
React style, right, where it observes, decides, acts, gets feedback.
Exactly. Observes, decides maybe call a tool, maybe take an action, gets the feedback, and then just repeats that whole process. It's quite straightforward at its core.
So, okay, if that fundamental loop is the same, what actually gives these agents that deep capability? What's the secret sauce? How do they go from basic back and forth to, sophisticated problem solving?
That is the key question. In the LangChain video, What are Deep Agents? Nails it. The secret isn't a new loop, but it lies in four really ingenious design characteristics. These are a sophisticated planning tool, the use of subagents, access to a dedicated file system, and a very, very detailed system prompt. It's these elements together that really transform how the AI operates and let it handle that complexity.
Right, okay, four pillars. That makes sense. So these are what empower them to go from simple to truly sophisticated. Let's dig into each one. Starting with that planning tool. I mean, imagine trying to build a house without blueprints, right? It'd be
Yeah.
chaos.
Total chaos.
And standard LLMs, they often struggle with long, multi-step tasks exactly because they lack that persistent plan. They might solve one step brilliantly, but then completely lose sight of the overall goal. So the planning tool, it provides that roadmap, that continuous guide, allows them to act cohesively over time.
Precisely. It's like that architect meticulously sketching out the whole project first. And what's really clever about this planning tool, like the to-do right tool used by Claude Code, is how surprisingly simple its actual mechanics can be. The LangChain sources make it clear it's not doing complex data structuring or anything like that. It's almost a Noop tool, functionally.
A Noop tool, so it doesn't do much itself.
Not directly, no. Its genius lies in letting the AI itself generate and, crucially, continuously update a to-do list. And then that list gets fed back into the agent's active memory, its context. So this self-referential planning helps the agent stay organized. It just keeps seeing its own plan evolving. Right. And maybe counterintuitively, this simple list doesn't just help memory. It actively sort of rewires the LLM's long-term reasoning. It helps prevent goal drift getting stuck, that kind of thing.
Ah, okay. So it's like a dynamic internal compass for these complex projects.
Exactly. And in the Deep Agents package, this to-do list is dynamically maintained right within the agent's state. So the plan is always present, always guiding the next step.
That makes sense. It's like having that super organized friend with the perfect to-do list, unlike my scribbled notes. Okay, next up, sub-agents. So these are like AI's way of delegating tasks. Is that the idea?
That's a great way to put it. Delegation.
So when the main agent hits a really complex side quest, or needs some specialized info, it can just spin up a dedicated subagent.
Exactly. Spin up a specialist to handle just that piece.
Kind of like a CEO delegating some complex research to a dedicated team, maybe? And then just getting the summary back, not all the messy details.
Precisely. And you might ask, well, why not just give the main agent more tools? Why are subagents so much more powerful?
Yeah, what's the specific advantage?
So the LangChain sources, drawing from Anthropic's work, highlight a few key benefits. Probably the most profound one is isolating context. It's huge. Each subagent operates in its own little bubble, its own environment. This stops what they call context pollution.
Context pollution, like the main agent getting overwhelmed with too much info.
Exactly. A really complex problem can just swamp the main agent's memory or focus. Subagents allow for this, like surgical focus, without losing the big picture.
Mhm.
And it also means subagents can have really specialized prompts or tools, hyper-focused. Plus, you get reusability, build a subagent once, use it in different projects, and you can give them fine-grained permissions, too.
Okay, that makes a lot of sense. That isolation is clever. But does that complete isolation ever cause issues? Like, does the main agent sometimes miss the why behind the subagent's findings if it only gets the final summary?
That's a really sharp question, and it points to a critical design choice in the deep agents framework they discuss. The CreateTask tool manages these subagents, right? And when one launches, its message context is basically reset, laser focus on its task. But crucially, it's designed so that only the subagent's final message gets sent back to the main agent.
Only the final message.
Yeah, all the intermediate steps, all the internal reasoning, stays within the subagent's isolated world, which means, practically, the subagent absolutely has to be prompted correctly. It needs to know to synthesize everything important to that very last message. It's definitely a trade-off, efficiency and focus versus maybe losing some of that intermediate rationale.
Right. Got it. Okay, third pillar then. The file system. This one sounds intriguing. So the challenge is, LLMs have limited short-term memory, their context window.
Right.
Trying to keep everything active at once, you'd just get overwhelmed. Exactly like our own short-term memory, yeah. Too much info degrades performance or you just run out of space.
So if the context window is like short-term memory, what's the clever solution they found for, like, long-term memory?
Well, the brilliant solution, as LangChain details it, is basically giving them an external hard drive, a file system.
A file system, like on the computer.
Not quite your actual C drive, no. What's fascinating is how it allows agents to offload context. Instead of stuffing huge chunks of text, maybe research findings or long documents into the LLM's active memory, the agent can just store them in files within this system and then refer to those files with short notes in its main context. It can then deliberately choose to read from or write to these files when it needs the information without being constantly burdened by it all.
Ah, so it accesses it on demand.
Exactly. And importantly, in the deep agents implementation LangChain describes, it's a virtual file system. It's essentially just like a dictionary or a similar structure within the agent's running state. Makes it super scalable and easy to manage. And the package comes with tools for this. REST to list files, read file.
Standard stuff, okay.
Yeah, but read file can even specify line numbers, which is handy. That's write file, obviously. And a unique edit file tool.
Edit file. How does that work? Is it like a text editor?
It's interesting. It performs exact string replacements.
Oh, okay. That sounds specific. Why that way?
It might seem a bit unusual compared to how we edit text, yeah. But the LangChain team explains that models like Claude are actually specifically trained to use this kind of function effectively. It simplifies the interaction for the AI, makes it more reliable for the model to perform edits predictably. There are some nuances they note, like handling concurrent edits to the same file, but overall it's designed for robust AI interaction.
Huh. Okay, trained for exact string replacement. Interesting. All right, that brings us to the final pillar, the detailed system prompt. Now, if you've played around with AI, you probably think you know prompts. But for deep agents, this sounds like it's on another level. It seems like a common misconception that these super powerful LLMs only need, like, a short, simple instruction.
Oh yeah, that's a huge misconception.
No.
The LangChain sources really drive this home, these prompts. They can be hundreds, maybe even thousands of lines long.
Thousands? Wow.
Seriously. Take Anthropic's deep research system prompt they mentioned apparently. It's incredibly extensive. And the prompt isn't just telling the AI what goal to achieve. Critically, it's instructing it how to use all these other tools effectively, how to use the planning tool, how to navigate the file system, how to coordinate its subagents. It even defines, like, the AI's persona or behavior during the task, how it should format output, its problem-solving approach. It's the whole operating manual.
So the real intelligence isn't just the base LLM, it's how it's guided by this massive prompt and the tools.
A huge part of it, yes. And specifically in the deep agents framework, while you provide your custom instructions, a lot of the operational intelligence is actually embedded within the detailed descriptions of the tools themselves. That's where the AI learns the real nuances of how to interact with its planning, files, and subagents. It's quite intricate.
Okay, so we have these four powerful pillars: planning, subagents, file system, detailed prompt. How does this all actually come together? Do you have to, like, painstakingly code all this intricate stuff from scratch every time? That sounds daunting.
Well, that's the good news. You don't. The LangChain team has done a lot of the heavy lifting. What's really cool here is that the Deep Agents Python package they provide offers this off-the-shelf scaffolding for building these agents.
Ah, so it's like a starter kit.
Pretty much. It comes pre-built with the planning tool, the virtual file system tools, the tool for creating subagents, and a solid foundational system prompt.
Hmm.
And the package itself is built right on top of LangGraph.
LangGraph, that's LangChain's agent runtime, right? For managing the steps.
Exactly. It's designed specifically to handle these complex, graph-like execution paths that deep agents often take. So basically, a developer can just pip install deep agents, and then their main focus shifts to providing their specific custom instructions for the task, and maybe adding any extra custom tools they need, like a specific search tool or a calculator, whatever fits their use case.
So it makes building these complex agents way more accessible.
Definitely. It significantly simplifies developing agents for tough tasks like deep research or complex coding, puts this cutting-edge AI within reach for more people.
Okay, so let's bring it back. What does all this mean for you listening in? If you're someone who likes to get up to speed quickly on complex topics, well, understanding deep agents really offers a compelling glimpse into where AI is heading. This isn't just about making AIs, a tiny bit smarter. It feels like it's about enabling them to tackle genuinely multifaceted real-world problems. Things like conducting really in-depth research or writing complex software, generating comprehensive reports, all autonomously. It's really about AI that can take initiative, manage complexity, manage projects.
Yeah, and it does raise that important question, doesn't it? As these agents keep evolving with better planning, better delegation, better memory, how are they going to reshape industries,
Huh.
our daily lives, and maybe what new kinds of collaboration become possible when AI can manage tasks with this level of autonomy and depth? It could really free up human talent for maybe more creative, more strategic thinking.
Absolutely. Lots to think about there. Well, that wraps up our deep dive into the fascinating world of deep agents. We really hope this gave you some of those aha moments, and a clear picture of what makes these next-gen AIs just so incredibly powerful. If you found this deep dive valuable, or maybe if you're already dreaming up ways you'd use a deep agent yourself, we'd love to hear from you. Hit like and subscribe if you like the content. See you next time.